Hello everyone, once again welcome back to my YouTube channel. Earlier we had discussed two topics, electric field intensity on an axial line of a dipole and electric field intensity on an equatorial line of a dipole. But now we are going to talk about electric field intensity at any point which neither lies on an axial line of a dipole nor lies on an equatorial line of a dipole. So in order to discuss this article, we first of all need a pair of equal and opposite charges separated by a very small distance. So these are the pair of equal and opposite charges such that plus q charge is supposed to be placed at point A and minus q charge is supposed to be placed at point B, and these are separated by a very small distance 2a such that dipole moment acts from the negative charge towards the positive charge and is marked as small p vector. And the definition of the dipole moment says that dipole moment is equal to product of length of the dipole with the magnitude of either charge, that is p vector is equal to 2aq. Now the point of observation is lying such that this point is neither on the axial line of a dipole nor on the equatorial line of the dipole. Therefore, its distance has to be considered from the center of the dipole. Let us mark the center of the dipole to be O, and let us take this separation from O to P as R vector. As this diagram clearly indicates that dipole moment is making an angle theta with the line OP, therefore its rectangular component P cos theta will act along the line OP. And I just want to extend this line further because this point of observation P is lying on the axial line of the rectangular component P cos theta. But I also need to find its another rectangular component, that is P sin theta, and in order to find the component P sin theta, what I have to do, I have to make a perpendicular line to P cos theta. So I am making it along OX. Now it is a clear indication that a line OP extended further is making an angle of 90 degree with this line OX. Therefore, the component P sin theta will act along OX direction. Why I have made the perpendicular along this direction rather than making this perpendicular line along this direction? There is a possibility that I could make a perpendicular line to component P cos theta along this direction, but I have not made it along this direction. I have preferred to make it over this direction, and the reason is that I need my resultant to be contained between P cos theta and P sin theta. So these two perpendicular lines which are acting along OP and OX are taking the resultant midway. That is why I have taken the component P sin theta along OX line. Now if we clearly observe this point P is lying on the axial line of component P cos theta. Therefore, electric field because of component P cos theta will act along the extended line OP. Let us take this distance as Q, that is OQ, and the electric field intensity because of P cos theta component will be along PQ and will be written as E1. Also, this point of observation P is lying along the equatorial line of a component P sin theta. Therefore, the electric field intensity will act along PY direction, and I will mark this electric field intensity as E2. Now, how I can say that this Py also represents the component P sin theta? If we carefully observe this particular line Py and OX, we can see that these two lines are parallel. Therefore, if this OX is representing P sin theta, therefore this Py will also represent P sin theta, and hence I can say P point is lying along the axial line of the component P cos theta, while P point is lying on the equatorial line of the component P sin theta. Now, if we carefully observe these vectors, E1 vector and E2 vector, these two vectors are originating from the same point of observation P. Now, we have to recall the definition of parallelogram law of vector addition, according to which if two vectors are represented in magnitude and direction by the two adjacent sides of a parallelogram, then the resultant is represented by the diagonal of the parallelogram. That means if I want to find the resultant of E1 and E2, then I have to complete this parallelogram. So I am completing it by making a line parallel to PQ and a line parallel to PY, and hence now I can locate my resultant. So my resultant will act along this direction and I will take it as E. Now applying the resultant rule for the parallelogram law, I will have R is equal to under root of P square plus Q square plus 2PQ cos theta. But here R is equivalent to E, P is equivalent to E1, and Q is equivalent to E2, and it is already clear to us that E1 and E2 are perpendicular to each other. Therefore theta is equal to 90 degree. Hence this equation will change to, this equation number 1 will change to E is equal to under root of E1 square plus E2 square plus 2E1 E2 cos 90, and we are already aware cos 90 is 0, therefore this term will turn out to be 0. This implies we have E is equal to under root of E1 square plus E2 square. So I will mark it as equation number 2 because this equation is the equation which is going to help us to solve the article further. Now as we have discussed, E1 is the electric field intensity at point P because of the component P cos theta, and P point is lying on the axial line of the component P cos theta, and E2 is the electric field intensity because of the component P sin theta, and P point of observation is lying on the equatorial line of the component P sin theta, and hence we can write the equations for E1 and E2, that is E1 is equal to 1 upon 4 pi epsilon naught 2p cos theta upon r cube, because the expression for axial line was 1 upon 4 pi epsilon naught 2p upon r cube. Instead of writing x cube, I have just put r cube, and for equatorial line the expression was 1 upon 4 pi epsilon naught p upon r cube. Now since E1 is because of the component P cos theta, that is why for E1 I have put 2P cos theta instead of writing only P, and E2 is lying on the equatorial. E2 is because of the equatorial component P sin theta. P point is lying on the equatorial line, that is E2 is because of the component P sin theta. Therefore the expression for E2 will be E2 is equal to 1 upon 4 pi epsilon naught P sin theta upon r cube. So these are our equation numbers 3 and 4, and what we have to do right now, the only thing which is left is to put the equation number 3 and 4 in equation number 2. Therefore using 3 and 4 into, we get E is equal to under root of E1 square, and instead of writing E1 square I will write 1 upon 4 pi epsilon naught 2p cos theta upon r cube whole square plus 1 upon 4 pi epsilon naught p sin theta upon r cube whole square. So solving this equation we will get E is equal to under root of 1 upon 4 pi epsilon naught 2p cos theta upon r cube, and what I am going to do, I am just separating out this square value and whole square, and like this in the second term again I can take it as 1 upon 4 pi epsilon naught whole square p sin theta whole square and separating r cube whole square. So we are having the equation that is equal to under root of 1 upon 4 pi epsilon naught r cube whole square multiplied by 2p cos theta whole square plus 1 upon 4 pi epsilon naught r cube whole square p sin theta whole square. So further solving it, we will be having E is equal to under root, taking 1 upon 4 pi epsilon naught r cube whole square common, we will be left with 2p cos theta whole square plus p sin theta whole square. Now again solving it further, we will get a value, that is, just take first of all take this square out of the under root, because this square and this under root will cancel out each other. So we will be having 1 upon 4 pi epsilon naught r cube taken out of the under root, and inside the under root we have a value 4p square cos square theta plus p square sin square theta. Now I can take p square common once again, so I will write 1 upon 4 pi epsilon naught r cube as it is outside the under root, and inside the under root I will take p square common, and I will be left with 4 cos square theta plus sin square theta. Now I will take p square outside, and I will perform one more calculation, that is p upon 4 pi epsilon naught r cube under root. Instead of writing 4 cos square theta directly, I will write 3 cos square theta plus cos square theta plus sin square theta as it is. I just have divided 4 cos square theta into two parts, because I have 4 cos square theta. I can write it as cos square theta plus cos square theta plus cos square theta plus cos square theta. But what I have done, I have taken these three parts along, that is 3 cos square theta plus keeping this part separate plus cos square theta. That is why I have just divided 4 cos square theta into two parts, 3 cos square theta plus cos square theta, and here we are having sin square theta, so I have just forgot to put square over here. So substituting this value, what we are going to do, we are just going to combine this value. We have E is equal to p upon 4 pi epsilon naught r cube under root of 3 cos square theta, and we already know cos square theta plus sin square theta is equal to 1. Therefore, using this trigonometric identity, I will put a 1 over here. So this is the expression for the resultant electric field intensity at a point, which point neither lies on the axial line of the dipole nor lies on the equatorial line of the dipole. Sorry, this is equation number 5. Now we need to find the direction also, as this resultant is making an alpha angle with even field. Therefore, from this diagram, just make it sure that this particular line is parallel to py, therefore its value is e2, and pq is already e1, and we need to find the direction. And to find the direction, we always take tangent function. So tangent is a function which always defines the direction. So in order to find the direction of the resultant, we will have to take a tangent function, that is tan alpha is equal to perpendicular upon base, and I have already taught you that in order to find the perpendicular, we just have to look over the angle. So the line which is in front of the angle is a perpendicular. So this line is a perpendicular line and its value is e2. So we have tan alpha is equal to perpendicular upon base. That means e2 is acting as a perpendicular and e1 is acting as a base. So I will write it as e2 upon e1. Hence the direction, in order to find the direction, therefore direction of E is given by tangent alpha is equal to e2 upon e1. Again, using equation number 3 and 4, we can put the values. From equation number 4, we have value of e2 as 1 upon 4 pi epsilon naught sin theta upon r cube. Therefore, I will write it as 1 upon 4 pi epsilon naught p sin theta upon r cube, and instead of writing e1, I will write the value 1 upon 4 pi epsilon naught 2p cos theta upon r cube. So clearly we can cancel out this term, this and this term. We can also cancel out p with p. So we are left with p sin, p is cancelled out, sin theta upon 2 cos theta. Therefore, I can say tangent of alpha is equal to 1 by 2 tangent theta. So this expression gives us the relation between the direction of the resultant electric field intensity and tangent of theta, that is the distance of the point of observation, that is the angle theta, which is made by the dipole moment with the OP distance. So this is all about the electric field intensity on the point which is not lying on the axial line of the dipole and is not lying on the equatorial line of the dipole. Thank you for watching this video. If you have understood the article, kindly let me know in the comment section, and do not forget to hit like button, subscribe and share my channel. And just let me know if you would like to get more videos in a bi language, that is in Hindi language also. So your comments will matter a lot. Thank you for watching this video.